here is the question I want to set up, and then I will walk you through the process of finding dominant species. So for example, I ask you to find the dominant species with DI water plus, let's say that 10 to minus 3 more of NaHCO3 plus, let's say that 10 to minus 3 more of HCl and plus 10 to minus more of NH4. Ammonia chloride, okay? Okay. If the question is like this, so find the dominant species. And write the total H equation, okay? That is what I'm going to do. So first step, when you want to write a dominant species, the first step is collect all the hydronium ion. So you collect all the H plus to the pocket first, okay? So the first step, collect H plus. So I'm going to call it H plus available. How much H plus available right now? So whatever you have H plus, I want to collect it. So how much, if you look at this, how much H plus I can have? 3 times 10 to minus 3, right? 1 from where? 1 from that HCO3 minus go to CO3 2 minus. So the first one is this one, right? This one, you have H here. So I asked the system, give me, when I write it, I want collect it first. So I got 10 to minus 3 from this one. Okay? That makes sense? And the second one, of course, is from HCl. This HCl you put into the solution, the H plus automatically dissociate. Now the third one is from NH4 plus, right? That NH4 plus will go to NH3, okay? And you have H plus over there as well. So now you see, I collect H 10 to minus 3 H plus from bicarbonate and from hydrochloric acid and then from ammonium, okay? So now I collect all the H plus and all the acid go to the base. And now I'm going to distribute the H back to those base based on pKa value. The higher the pKa value, it means that that base can grab H plus more strongly, okay? So he have a much higher power to collect that H plus. So the second step is to, I'm going to say arrange, okay? Arrange acid and base pairs based on pKa, okay? So that's what I'm going to do now, based on pKa. So now I'm going to write like this. Acid and base. So the first group will which one? We have bicarbonate and carbonate. The pK value is 10.35, right? And ammonium to ammonia, the pK value is 9.35 or something. So the first one will be 10.33, okay? So that will be the first one. Okay, and the pK value is 10.33, and the total A is how much? 10 to minus 3, right? Remember, we collect all the H plus. Now HCO3 2 minus. It's 10 to minus 3 sit there waiting for H plus to be distributed back. Okay, so I say that's 10 to minus 3 right now. And then you will have, this time I'm going to say H remain, okay? Because I have 3 times 10 to minus 3, and then I will start distribute back, and I hope that how much it will be remain. So the first one is that, okay, I have 3 times 10 to minus 3, and I want to distribute back to this one, right? So when you distribute back, this CO3 to minus will go to HCO3 minus, okay? So that is the part we will do later on. And then the second pair will be ammonium and ammonia. This is 9.35 and 10 to minus 3 right now as well. And the third one, if possible, it will go to this H2CO3 and HCO3 minus, right? And this one is 6.35. Do I have anything here? At this point, no. Remember, we everything go to their basic form, right? So there's nothing here. So don't fill in anything right now, okay? So I think that's about it. And I know a lot of you write OH minus. That is when we had NaOH, you would write it, but now we don't have NaOH, so we don't have that pair, okay? A lot of people make mistake on that one. So now, I'm going to distribute back. So the first thing is that I'm going to get 10 to minus 3 to this one. So when I give it, this is gone, right? 10 to minus 3 is gone, and I got 10 to minus 3 here. It converted to what? HCO3 minus now, right? So, and how much H plus available right now? I have 3 10 to minus 3, and I get rid of 10 to minus 3, so I only have 2 times 10 to minus 3, right? So that is the first part. And then I'm going to distribute this one to this one, right? So this NH4 plus will become the dominant species, and then I only have 10 to minus 3 left because this one to this one, right? Look like I still have something. So this one will go to this one and get rid of this one. So it becomes 0. So I have 2 dominant species identified here, NH4 plus and NH2CO3. So these are 2 dominant species, and I'm going to use it for writing total H equation. So this part, I'm going to write reference here. Okay. So I put the dominant species on the reference and then write the corresponding base or acid based on that reference. With that, I can say, okay, what is the total H in? Total H in, you have to look at how much H plus you put in, minus, if you put any OH minus in, put HCO3 minus in, minus 2 CO3, 2 minus, and minus NH3, right? So that will be the total H in. You write the H plus, the plus 1 minus the OH, HCO3 minus, and NH3, and minus 2 times of CO3 2 minus. So in here, you take a look. The first part is that, have you put any H plus in here? Look at, did you put any H plus in? Which one? HCl, right? That HCl you put in and it will just dissociate the very strong acid. So you put 10 to minus 3 of H plus in. Have you put any OH minus in? No, we don't do anything. So this is 0. Have you put HCO3 minus in bicarbonate? Yes, here, right? You have sodium bicarbonate. That is the salt. You put it in, you have sodium and bicarbonate. So that's 10 to minus 3, right? Oops, here. Do you put bicarbonate? No. Do you put ammonia? No, we put ammonium, right? So it's 0. So at the end, 10 to minus 3 minus 10 to minus 3, it will become 0. Very important. If you have the right dominant species identified, and you write it based on that dominant species for the total H, usually total H in will be very small. The best will be 0, okay? Remember, we want it to be 0. And total H in equal to what? Total H equilibrium. So it means that the total H equilibrium, I'm going to put the other one. The total H equilibrium is that when it reaches equilibrium, that H plus minus OH minus bicarbonate minus 2 times of carbonate minus ammonia has to be equal to total H in, right? And equal to 0 because we calculate equal to 0. So in your equation, you just find this one where work low. Okay? Good? Okay, so that's how it works. I hope you can understand. If no question, I will let you work on one. Okay? So this is the new one for you to work on, and I hope that you can follow. I just add NaOH in, okay? And you can do it.